I didn't think of filming the repair at the time because I didn't think anyone would need it, so I've got no actual footage. But then I thought, what if someone's stuck with one of these $700 lumps and they can't repair it because there's no spares? It's basically a short run one-off with no support, so when it blows you have to toss it because you can't do anything with it. The plug says XL Air EPA 14A. The symptoms were it was totally dead, no LED, no beep, no nothing. From memory, just unscrew all the screws in the back. I think there was some in these handles, and that they need a very long Phillips head. Then I think there was 2 screws under this cover, so you have to pop it off with some spudges, then just slide the back section off. I don't have actual pictures with the cover off, but there's a black electrical box right here. And this is what the circuit board in the box looked like. This is the warning section. This thing has live mains voltage, so it can kill you quite easily. So don't do what I did. Plus these capacitors will give you a big kick if you don't discharge them. So be careful touching any of the tracks on the underside of this PCB or any metal parts. You have to drain the caps between these 2 pads. Even though it's not recommended, I think you can put a screwdriver across the pins of the power plug, even though the preference is to slowly drain it with a resistor. If you want to do it with a resistor, just grab a 10K and a pair of insulated pliers and put it across the 2 pins. The first thing you check is if the fuse is blown or any MOVs or inlet protection, and since mine was fine, I did this next. You probably won't have to do this after I show you what happened, so you can save electrocuting yourself. But I unplugged this fan and then this big plug, then all the earths except one. I kept the mains lead blue neutral connected, and I think it's this one. I also kept the mains brown active connected to the relay, and I think it's this one. Just check where your mains lead is connected, in case I'm wrong. I think this is the relay output, and you don't need that either. And lastly, this plug. I don't know really what I'm doing, but the first rule of repairing electronics is thou must check voltages. I had a hunch, since everything was dead at the top where the microcontroller is, that its power supply wasn't working. And on the board it's conveniently marked at this plug. Danger section next. I plugged in the mains and checked the marked voltage pins to the ground pin, and there was no 5 volt. And that kind of indicated the power supply wasn't working. I don't really know, but I assume this is a flyback topology switch mode power supply. Diode's gone wild analyzes so many of these switch mode power supplies, it's like he's changing his underwear, and most of the cheap stuff is flyback topology. Of the little I know from watching YouTube videos, the power comes in through the fuse, through this filtering system, and then a full bridge rectifier, then through these smoothing capacitors, and then onto this transformer. I think there's some sort of voltage doubler here, so you're now up to 400 volts, and then the output is controlled by this IC. The IC is missing, but I'll tell you why later. The way this controller works is it senses the voltage and then adjusts the PWM until the output voltage is correct. This THX202 controller was my first suspicion, so it's either not switching, not sensing, or hasn't got a start signal. This is where stuff got dangerous. I plugged in the microcontroller, switched on the mains, and started probing the back. I was probing between the transformer and the control IC for the switch mode controller start voltage, and the thing beeped and the LED display turned on. The digital multimeter has a lot of internal resistance, but it let enough voltage through to the controller that it started. And this is where I made a big mistake. I plugged all the motors back in and started probing the pads to get the controller working again, but I must have touched the wrong one because the thing exploded. The controller IC exploded and this resistor exploded. At this stage I was going to give up because clearly I didn't know what I was doing and didn't know enough to diagnose this circuit. But then I thought, there's only 40 parts, so why don't I just take them off one by one and check them? It's slow, but you don't need a brain, which is right up my alley. So it's take each part out one by one, put it in a transistor checker. If it's good, put it back. If it's bad, replace it. You only really have to remove half the parts because there'll be so many cut connections of the other halves you can test on the board. As per usual, I got it wrong and started with the delicate parts like diodes and capacitors, which it wasn't any of them, and it's only after I checked everything that I got onto the resistors. Now I wouldn't expect resistors to fail unless there's an obvious burn mark on them, but I was sort of clutching at straws, so I had to test them all. And that's when I found one of these white resistors had gone open circuit. These white resistors seem to be some sort of a safety resistor that has a fuse in it, so when it blows there's no burn mark to indicate a failure. The value was 2.2 mega ohm, but because it's in a voltage divider you should change them in a matched pair. I was originally going to throw some carbon resistors in there, but then I thought if they shorted they would catch fire. Same with metal film. In the end I bought some expensive white ones because I thought it'd be safer. I had to use 1 watt because that's all they had on eBay, and then I had to go through all 50 for a matched pair in resistance. The very last part I checked was this inductor, and it was open circuit too. This might have blown up when I blew up the PCB, like the resistor next to it, so it might not be failed on yours. I found a 1 microhenry, but it was a 1 watt, so I had to use that. The blower resistor was 4.7k. Luckily I took a photo of before it blew up, so I was able to read yellow, purple, red. So make sure to take a lot of photos on the way, just in case. I laid out all the part numbers, so you might be able to read them off this. I actually went halfway to laying out a PCB, but I didn't need it in the end. In the end, we nearly tossed a $700 air conditioner for a 10-cent part. On a side note, if you want to know what these indoor air conditioners are like, well, they're never going to be as cold as an indoor-outdoor wall-mounted system, so the best it can do is just a refrigerated blower. Basically, it's a lot better than a fan, but it's not as cold as a wall-mounted air conditioner.